Hello everyone, today we will discuss about a question from CSIR NET December 2024. The question is from complex analysis. The question says that for integers mn greater than equal to 1, let imn is equal to 1 by 2 pi I integration over c z to the power m into complex conjugate of z to the power n dz, where c is the circle, Z belongs to complex numbers, set of all complex numbers such that mod Z is equal to 1, that is over the unit circle, oriented counterclockwise. Each of the following statement is true. Here the integration Imn is taken over the circle C, which is mod Z is equal to 1. Now mod Z is equal to 1, this implies Z into Z bar is equal to 1. This implies Z bar is equal to 1 by Z. So, we can put the value of Z bar is equal to 1 by Z in the integration Imn. Imn is equal to 1 by 2 pi I integration over C Z to the power n into 1 by Z whole to the power n dz. Therefore, Imn is equal to 1 by 2 pi I integration over C Z to the power n into Z to the power minus n dz. That is, Imn is equal to 1 by 2 pi I integration over C Z to the power m minus n dz. Now first we verify the option 1. So first we consider the case when m is equal to n. If m is equal to n, then Imn is equal to 1 by 2 pi I integration over C Z to the power m minus n dz. Therefore, Imn is equal to 1 by 2 pi I integration over C 1 into dz. Here we use the Cauchy's theorem. This is Cauchy's theorem or Cauchy-Goursat theorem. This theorem states that if a function fz is analytic and one valued inside and on a simple closed contour C, then integration over C is equal to integration over C fz dz is equal to 0. Here in option 1 we get fz is equal to 1, which is analytic on a simple closed curve inside and on a simple closed curve C, which is mod Z is equal to 1. So here we use this theorem. Therefore, by Cauchy-Goursat theorem, integration over C 1 dz is equal to 0. Therefore, Imn is equal to 1 by 2 pi I into 0. This is equal to 0. Therefore, option 1 is incorrect, because in this case we get Imn is equal to 0, not 1. Now we check the option 2. Option 2 is when n is equal to m plus 1. Let us check this case. If m plus 1 is equal to n, then Imn is equal to 1 by 2 pi I integration over C Z to the power m into Z to the power minus m plus 1 dz. This is equal to 1 by 2 pi I integration over C 1 by Z dz. Now we compute this integration by using Cauchy's integral formula. Cauchy's integral formula states that if fz is analytic within and on a closed contour C and A is any point within C, then f is equal to 1 by 2 pi I integration over C fz by z minus A into dz. Now, in option 2, here fz is equal to 1, A is equal to 0, which is inside the closed contour C. Unit circle mod z is equal to 1. Therefore, here we can use this Cauchy's integral theorem. Therefore, by using Cauchy's integral theorem, we get here this is equal to 1 by 2 pi I into 2 pi I. This is equal to 1. Therefore, option 2 is correct. Now, we check option 3 and 4. In option 3, n is equal to n plus 1. If n is equal to n plus 1, then Imn is equal to 1 by 2 pi I into integration over C z to the power n plus 1 into z to the power minus n dz. This is equal to 1 by 2 pi I integration over C z dz. Now here we use Cauchy-Goursat theorem where fz is equal to z is analytic within and on a simple closed curve C mod z is equal to 1. So the value of this integration is equal to 0. Therefore, is equal to 1 by 2 pi I into 0. This is equal to 0. So option 3 is incorrect. Now option 4, m is equal to n plus 2. If m is equal to n plus 2, then Imn is equal to 1 by 2 pi I integration over C z to the power n plus 2 into z to the power minus n dz. This is equal to 1 by 2 pi I integration over C z square dz. Similarly, here we can use the Cauchy-Goursat theorem where fz is equal to z square, which is analytic within, inside and on a simple closed curve C, which is mod z is equal to 1. So the value of this integral is equal to 0. Value of this integration is equal to 0. Therefore, 1 by 2 pi I into 0, this is equal to 0. Therefore, option 4 is also incorrect. So, the correct answer is option 2. Option 2 is the correct option. Thank you.